You clicked on this video because you are worried about the security of apps built by non-developers using AI. You know that when product managers or data scientists start writing code with tools like GitHub Copilot, they often bypass the standard guardrails your engineering team has spent years building. The real stakes here are terrifyingly high because functional code is not secure code. You will learn why 90% of these AI-generated apps contain hidden vulnerabilities and discover a specific architectural pattern called the shadow LLM that can secure them without killing the productivity that made you want to use them in the first place. Let us start with a number that should keep you up at night. Recent data scanning over 5,600 deployed applications built by non-developers reveals a stark reality. While 61% of the code generated by these teams is functionally correct, only 10.5% is actually secure. That means if you have an app that works perfectly, there is a 90% chance it has a security flaw waiting to be exploited. This is not a minor issue. It is a systemic failure born from a practice known as vibe coding. Vibe coding happens when teams rely on the feeling that the code is right because it runs, rather than verifying the underlying logic. Non-developers using AI assistants create shadow LLMs that operate outside your enterprise control plane. These tools generate code that looks indistinguishable from legitimate internal applications, yet they bypass the standard security protocols you rely on. The result is a hidden security debt that accumulates silently until a breach occurs. Consider the specific failure mode observed in these apps. A scan of the deployed applications found over 2,000 vulnerabilities and 400 exposed secrets hidden in plain sight. The most dangerous aspect is that 45% of security-relevant scenarios contain vulnerabilities. This means that when a non-developer asks an AI to build a login form or a database connection, the AI might write code that works for the test case but leaves the door wide open for an attacker. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The problem is that current automated tools are not designed to catch this specific type of risk. Standard CI pipelines and post-hoc scanning tools look for known patterns in established codebases. They assume the developer understands the security implications of the code they are writing. But when a product manager is the one writing the code, they are not thinking about SQL injection or broken access control. They are thinking about shipping a feature. Because of this gap, the AI generates code that satisfies the functional requirement but ignores the security context. This leads to a critical knowledge gap in how we approach modern development. We are seeing 17 specific vulnerability categories, including misconfigured databases and broken access control, responsible for most real-world breaches. These issues require human-led verification for edge cases like data isolation. Yet, we are asking AI to solve these problems without any human oversight. The result is a double-edged sword where productivity skyrockets, but the attack surface becomes unmanageable. Here is the thing that changes everything. You do not need to stop vibe coding to secure your environment. You do not need to force non-developers to learn complex security protocols or wait for a full audit before they can ship a feature. The solution lies in shifting from blind trust to rigorous human oversight through a new architectural pattern. This pattern is the shadow LLM enforcement layer. Instead of relying on a single AI assistant that operates in isolation, you introduce a dedicated security agent that acts as a gatekeeper. This agent integrates directly into the coding assistant's context, forcing the AI to self-correct for common flaws like SQL injection and cross-site scripting before the code is even written. It operates as a specialized system prompt that mandates secure defaults, such as requiring the use of crypto.randomuid for identifiers and enforcing strict schema validation for all inputs. Think of this shadow LLM as a supervisor that never sleeps. Every time a non-developer generates code, the shadow LLM audits it against an agents.md policy file before any commit or deployment occurs. It does not just scan for errors. It understands the intent of the code and ensures that the implementation aligns with your security standards. This approach allows non-engineers to build apps rapidly while forcing secure defaults, effectively mitigating the 90% insecurity rate observed in unguided LLM usage. The impact of this shift is measurable. Evidence shows that prompt engineering combined with this enforcement layer can reduce weaknesses by 42.85%. However, it is important to acknowledge that this is not a panacea. Automated guardrails prevent common failures, but they cannot replace professional penetration testing for applications handling real user data. There are still edge cases that require human judgment, particularly when it comes to complex data isolation scenarios. The trade-off is that without a unified DevSecOps platform that offloads technical complexity, organizations face a hidden security debt where rapid prototyping creates an unmanageable attack surface. Standard CI/CD pipelines cannot detect the subtle drift that occurs when non-experts build non-standard internal applications. The shadow LLM pattern bridges this gap by creating a centralized control plane that enforces security via specialized system prompts. This ensures that even as the application evolves, the security posture remains consistent. Now consider the long-term implications. Current automated tools effectively catch foundational flaws, but they lack benchmarks for long-term architectural drift. As non-developers build more apps, the complexity of the system grows, and the risk of subtle security failures increases. The shadow LLM pattern provides a way to manage this drift by continuously auditing the code against a living policy file. This creates a feedback loop where the AI learns from the corrections and improves over time, reducing the burden on your security team. The synthesis of this data and strategy reveals a critical path forward. We must stop treating AI-generated code as a black box and start treating it as a dynamic system that requires active governance. By implementing the shadow LLM enforcement layer, you can harness the productivity of vibe coding while eliminating the hidden security debt. This approach allows your organization to move fast without breaking things, ensuring that every app built by every team, regardless of their background, meets the same high security standards. The future of development is not about choosing between speed and security. It is about building systems that enforce security by default, allowing everyone to contribute without compromising the integrity of your infrastructure. The shadow LLM is the key to unlocking this future. It transforms the way we think about AI-assisted development, turning a potential liability into a powerful asset. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.